The next law of exponents is essentially an extension of the last law. So this expression, 3x squared y to the fourth all cubed, means that I need to take this base of 3x squared y to the fourth and multiply it by itself 3 times. So now when I actually multiply these together, I'm going to multiply the coefficients, 3 times 3 times 3, which will make 27. And then my x's, I'm going to multiply by adding the exponents together. So 2 plus 2 plus 2 will be x to the sixth. And my y's, when I add the exponents, 4 plus 4 plus 4 will make 12. Now here's the thing you should notice, that if we go back to my original expression and kind of distribute this 3 as an exponent, as I do that, I'm going to get 3 to the third. I'm going to give the exponent to the coefficient. And then I'm going to do the same thing with the x. 2 raised to the third power, or 2 times 3 makes 6. And y to the fourth to the third, or 4 raised to the third power, will make a 12 from that last law. And notice 3 cubed is the same thing as 27, and we end up at that same answer. So this is the next law of exponents, that when you've got parentheses with multiplication or division inside of the parentheses, the exponent can be distributed to all the individual pieces. So on your index card, we're going to write x, y, z to the a is the same thing as x to the a, y to the a, z to the a. Every single piece in the parenthesis gets the exponent applied to it. And the same thing is true for division. If we're doing x divided by y, all to the a power, the numerator, all the pieces of the numerator get the exponent, and all the pieces of the denominator also get the exponent. Flip your index card to the other side and we'll do some practice using this law. So let's start with 2x to the negative fifth, all raised to the third power. Now again, you could write this out 3 times, 2x to the negative fifth times 2x to the negative fifth times 2x to the negative fifth, or we can use this last law, which is kind of a shortcut. We're going to distribute, if you will, this 3 into all the pieces. So I'm going to get a 2 to the third. And then for my x's, I'm going to have negative 5 raised to the third power, or negative 5 times 3, which will be negative 15. And then as we simplify this, 2 cubed, 2 times 2 times 2 makes 8. And x to the negative 15 is really 1 over x to the positive 15, which I could rewrite this all as 8 over x to the 15th power. Next one, negative 3 x squared y to the fourth, all to the fourth. So I'm going to have a negative 3 raised to the fourth power. And then my x, I'm going to have a 2 to the fourth, or 2 times 4, which is 8. And my y's are going to be a 4 raised to another 4, which will make 16. And now as I simplify this, negative 3 to the fourth power makes positive 81. X to the 8th, y to the 16th. Next, we'll do one with some division in the parentheses. This parenthesis should all be raised here to the third power. So everything in the parenthesis is going to be raised to the third power. So I'll write it like this. I'm going to have a 4 to the third, and then an x to the ninth from 3 times 3, over my denominator, which will be y to the fourth to the third, which will make to the 12th. And then as I simplify this, 4 cubed, 4 times 4 is 16, times another 4 is 64. X to the ninth, y to the 12th. And Lastly, here's a negative exponent outside the parentheses. So this is going to be a 4 to the negative 2 and x to the negative 4 all over y to the negative 3 times negative 2 makes a positive 6. So as I simplify this, 4 to the negative 2 is really 1 over 4 squared, or 16. X to the negative 4th is 1 over x to the 4th, all over y to the 6th, which in the numerator will become 1 over 16x to the 4th, all over y to the 6th. And now we have a fraction inside of a fraction, so let's simplify that a little bit. This will be the same thing as 1 over 16x to the 4th divided by y to the 6th, which will really be 1 over 16x to the 4th times 1 over y to the 6th. So our final answer is going to be 1 over 16x to the 4th y to the 6th. And lastly, a little word of caution here. This distributing of the exponent into the parentheses only works with multiplication and division. If we have x plus y squared, you cannot distribute that square, because keep in mind this means x plus y times x plus y, which we're going to have to FOIL out, and that'll give us x squared plus 2xy plus y squared. And the same thing would be true of subtraction. You cannot distribute the exponent with the subtraction there. Only multiplication and division.